Well, the basic idea underlying the project is that a key part of the solution to climate change and to the energy security challenges is innovation in the energy sector. Now, the question we set out to answer is, what is the optimal portfolio of energy research and development investment, R&D investments, in the energy sectors? And the way we'll do this is threefold. The first part of the project deals with the past. We look at data related to policies driving innovation and investment in R&D, and we'll try to understand the effects on some indicators of innovation, as for example patent data, and in the energy sector, and investment in energy technologies itself. Then we will look at the future, and the basic idea there is that there's not a deterministic relationship between R&D programs and the success of a technology. Rather, the relationship is probabilistic, and what we'll do is to elicit the opinion of experts to try to figure out what is this probability and how it depends on R&D investments. The final phase is that of projecting into the future through the aid of an integrated assessment model, the WICH model, which we will run in a stochastic framework to answer the question on the optimal energy R&D portfolio. A basic innovative idea is that we won't stop there. We want to make available to every modeler the data set that we will collect, so that every other modeler can improve their own models by mimicking better the innovation process. Other similar projects are underway in the US, in particular at Harvard University and Carnegie Mellon. We collaborate with these projects, but they have their focus is basically the US. Our focus is going to be more global, and we will really look into the issue of technology transfer and spillovers across countries. And we will also serve as a platform of data they in the US will collect, so that we will broadcast all the information available on expert dissertation on energy technology breakthroughs. Well, as I said, the project is made of different phases, and of course for each phase different research profiles are needed. For the first phase, econometric skills and the capacity of looking into patent data is very important. For the second phase, expert elicitation is a tough job. It's very important to know the protocol and the methodology, and to know how to write down a questionnaire for the experts. So we need somebody able to do that. And of course, each technology has its own very technical details, and to be able to really communicate with experts, you need to know, you need to make the right questions. So we need somebody who is an expert, an engineer, energy expert, who knows the details of each technologies we will look into. And finally, the projection part needs modeling capabilities. So we will have some very good modelers working on the project. Well, FEEM is a leading research center in climate, energy, and environmental economics. So, from a research standpoint, it was clear it's clearly a good choice. But that's not all. On top of that, FEEM has an important tradition of giving full independence to its own researchers, and I think that's very valuable. And there is an outstanding group of people working on the administrative part, on the organization of events and communication, and this enables researchers to think about research only, and that's also very important. The fact that the team was composed by women is just by chance. I mean, most of the best or most suited people to do the job were women, and I think that's interesting, because in some sense they will not only produce incredible research, but they will be taking care of their kids, and we will have some new kids during the project. I mean, that's an interesting experiment to see how that works out.